Hello guys, welcome to the tutorial of how to use machine learning to predict hospital readmissions. In the previous video, we have already completed some pre-processing tasks, that is dropping the bad data, recoding the non-numeric values, etc. In this video, I will continue with the further steps involved in pre-processing. So we have already saved our work done so far into a CSV file. Now we will load that pre-processed data again in the new notebook file. Now let's first have a look over the pre-processed file. So in this file you can see that some of the features are missing, as we are done with some of the pre-processing tasks. So we have dropped some of the features in the previous video. So now let's move towards Jupyter Notebook. So here, since we have created another Jupyter notebook file, so once again we have to import all those Python modules and libraries. After importing all these libraries, we have loaded the modified file, that is the data pre-processed file, into the data frame. And after displaying the size of the data frame using shape function, you can see the size of the data frame. So initially we had 50 features and now we are having 54 features. Now you can also display the top 10 rows of the dataset using head function. Now before proceeding further, we need to convert the data type of all these nominal features of data frame into object type. So we have converted all the data type of these features into object type, and let's see the output. So after checking the output, you can see the data types of encounter ID is object, patient number is also object, race is object, and you can refer to the name of features over here. Now let's move forward. Now in this part of the code we have used randint as it returns the random integer from low to high. So this is the lowest integer and this is the highest integer over here. And again we are creating a data frame over here, and we are having two features, L1 and L2. So after that, what we have done is we have computed using CORR function, we have computed pairwise correlation of columns excluding the null values. That means we have computed the pairwise correlation of columns for L1 and L2 excluding the none values. Now we have applied min-max scaler just to scale the features to a given range, and after applying min-max scaler and fit transform, this is the output which we have got, that is the correlation output. Also, one more thing I want to mention over here about fit transform is that it is a function which fit to data first, then transforms it. Now coming to the next part of the code, now we have to convert the age back to integer type. We have already converted the age into 1 to 10, but now we are converting age back to the integer type, that is the age which containing value 1 is assigned a value 5, age containing value 2 is assigned a value 15, then 25, then 35, then 45, and so on. And after that we have calculated the number of values of each particular age, like you can see over here. The number of patients having in the age range 1 is 160, number of patient in the range 2 is 690. After that, since we have converted age back to integer type, so here we are having the corresponding values of each age, that is, this is the number of patients having age 25, having age 95, and so on. Now in this particular code, we want to get the list of only numeric features. So after executing this code, to check the output, after typing this one, we got the output like this. Now in this part of code, we will be removing skewness and kurtosis using log transformation, as after analyzing the numerical features, it is revealed that many of the features are highly skewed and they had high kurtosis. So as a reference, the skew of a normal distribution is 0 and the axis kurtosis is returned by the kurtosis function for a normal distribution is 0, which would impact standardization. So features such as number of emergency visits, service utilization, number of inpatient admissions, and number of outpatient visits had high skew and kurtosis. Thus, we have performed log transformation where a skew or kurtosis beyond the limits of -2 less than equal to skew and kurtosis less than equal to 2. Also, since log 0 is not defined, so we decided to use the following rule. So the first rule is we will compute log x for any feature x if percentage of zeros in x is less than equal to 2% after removing the zeros. This ensured that we didn't bulk remove records that hold predictive power for other columns. And the second rule is to compute log 1p x, otherwise this formula I will be explaining in this code. So the second rule is compute log 1p x, that is this one, otherwise log 1p x means log x plus 1 while retaining the zeros. So in this part of the code, we have removed the skewness and kurtosis using the log transformation. That is, the skew value should be greater than 2 and the kurtosis value should be greater than 2. Sorry, the skew values should be less than -2 and the kurtosis value should be greater than 2, and then after that we will append yes, and this is the further code for that. After that we will print the values in the data frame, that is value before skewness, before applying skewness and kurtosis, and value after applying skewness and kurtosis. So we have displayed standard deviation as well over here. So we have displayed standard deviation before and standard deviation after. So to check out the stat data frame, we have typed this code. So you can see the values over here, skewness and kurtosis. Now we have performed the log transformation for the columns determined to be needing it above. So just to perform log transformation, the Python code is pretty straightforward. So we have created a new column and set it equal to np.log or np-log1p of the column to be transformed. Now in the next part of the code, again we are dropping the features having high skewness and kurtosis value, that is number outpatient, number inpatient, number emergency and service utilization. So let's check the shape of the data set. So we are not having all those features. So now again we are getting the list of only numeric features, and this is the output which we have got. Now again we are showing the list of features that are categorical, like the features in which we have categorized the values. Now again in this part of the code we are again dropping some of the features. So we are dropping individual diagnosis columns that have two granular disease information. We are dropping level 2 categorization, which was not comparable with any reference, and again we are dropping level 1 secondary and tertiary diagnosis as well. So after dropping all those features, let's check the output, that is the data set. So now let's come to interaction terms. So interaction terms means variables that have interdependent effects on readmissions. So we have created a list of interaction terms, like all these variables inside small brackets are interdependent, have interdependent effects on each other. So we have created an iteration as well on interaction terms. So now I'm done with this video. I will discuss about further steps in the next video. Thank you and stay tuned.